Recording. Okay guys, our recording is started and we will continue. So let's go back to the our JavaScript, right? This is the JavaScript, but I want to go to the JS revision section. Okay, JS revision section, right? And we looked at yesterday, you know, from here, basic, right? So I added a couple of topics on the advanced section, in advanced concept, right? So difference between var, let and const. What is the difference now, right? So we looked at, I mean, I talked about yesterday also a little bit, but we'll just get more details today, right? Let's go and look at that. Because this three, I mean, this variable, not variable, but I said this keyword, right? Var, let, const is very important. We'll talk about window object, browser context API. I'll just talk about that. I'll just give some theoretical concept on this. What is then stack, heap, and memory, right? Heap, memory. So stack, see, we're gonna in the algo data structure, right? We have to learn about stack, means how you're gonna create a stack with JavaScript program. Okay, stack and queue and all that. But I will just give slight definition, right? What exactly is this? What is this doing, right, in our JavaScript? Okay, and what is heap memory? I will talk about that little bit. Then execution context. Okay, so this one we talked during our JavaScript class a lot, right? But we'll repeat that again. Execution context, lexical environment, we'll talk about this again. So how to copy reference value, we saw that one yesterday, right? So that's okay. True and false, we talked about this yesterday. So you know, and then for each and for in, right? We'll do this one today. So I think that will be enough for today class. Function, callback function, higher order function, first class citizens. So these are the few things we have to go through, and there will be, I mean, we will be keep adding couple of more, right, in the future also. Then after we finish this one, then we're gonna do asynchronous programming, right? Remember async program, the promise, how to create promise. Then how you're gonna, when you fetch any data, right, something which takes time, how the process happens, right, all that. So async, await, and all that we're gonna look at. Then method, then and catch, so that will be next part after this, right? So in this one, even in the advanced, still I have to find out a couple of more important topic, right? So, and we're gonna include all that. So let's start with difference between var, let, and const. Var, let, and const, right? So we talked about this on yesterday class. Var is the old JavaScript. You can call it, if you divide JavaScript between two parts, old one and new one, right? The old one is ES5. Let's just assume old one is ES5 to make it more easy to understand, right? And the new one is ES6. They both come in the browser, right? They are already installed in our browser. Okay, they are there already. Both are there. So that's why we can use var, let, and const. Okay, now, so what is the difference between them, right? The first difference is the var is the old JavaScript ES5, and let and const is new JavaScript ES6. First different. Second one, right? What is second one? Let's look at here. Okay, var is a function scope, and let is a let and const is braces scope, right? So what is function scope and what is braces scope? So we will understand this with example. Okay, but a function scope means what? Something inside the function. When you create a variable inside the function, so if this abcd is a function, right, and you add a variable like var I equal to 0, let's say you added one variable called var I, simple. So this is a loop, right? Inside the function you have a loop. So if we call this function, what can happen? What will be the output? Anyone, can you answer what will be the output here if we execute that function?
It will return 0 to 11.
Okay. And what about this one? Okay, so this loop will return 0 to 11. Fine. When I become 12, it will terminate, right? Then what about this one? Do we get something here? The answer, whatever the output will be here. What will be the output here? So this is the most asked question in the interview. Okay. If var is a function scope, right? So how are you going to prove that? Or maybe what result we get here, right? They're going to ask you simply what will be the output here, in this line. Small answer, right? I mean, one line, I mean, just say one word, right? What will be the output here? That is undefined or anything from the I variable. So because what I said, right, var is a function scope. So once you create a variable inside the function, this ABCD is a function. Once you create variable inside this function, you can access that variable anywhere inside the function. Even you can access this I here because we are still inside the function, right? So you have access to this variable I. So this for loop will run until I is 12, right? I become 12 and it will stop. And then it will go, the control will move here and it will print I, that is 12. Clear now? Because var is a function scope. If you create variable with var inside the function, that means you have access to that variable anywhere inside that function. Clear now, guys? So that is what important thing to understand, right? Okay, everyone clear on that? Okay, let's experiment. I mean, let's try to run this code and check, right? So let's go back because this class is just to understand. Okay, it's not like quickly finish, right? Even you understand one line of code for today is still very good. Okay, so let's go back here. What I will do, right, I'm just gonna create so we had a revision, JS revision. I'll create new JavaScript. So script2.js, okay, and I'll link to my index page. I will make it 2 here, and this one I will comment out. Clear now, right? Whatever I add here, so let's bring that code from our, I'll just copy this, okay, simple enough, and put here. So in this code, what I said, it will, okay, let's make it 1, right? Let's start from 1. So it will go 1 2 3 4 5 6 7 8 9 10 11, right? I 11, and when I become 12 it will stop, and here it should print 12, right? Fine. So go live view and check now. Inspect the page, right, and let's check the answer. Okay, something went wrong. Yeah, something went wrong, right? What is that? What is that? So I created this script 2.js. Oh, sorry, I need to see, that's the mistake, right? I have a function I didn't execute, So I will say A, B, C, D, right? That is important. When you know, what is function? Function is a simple program, right? You have to call that function in order to get the output of the function. So, okay, now look at here. We print from 1 to 11, and then the last line 5, script 5, right, has that. See, the control on 5 has console log I, and that is 12, because I is already 12. How? The loop, this loop start with 1, it will print 1. Next time the loop will keep repeating now, right, until this condition is, the end is false. Okay, so as long as I is true, it will keep repeating, and it will go until 11, right? I is 11, 11 less than 12, yes, it will print 11. Then I plus plus, now I become 12. I say 12 less than 12, no, it will stop. Now the control go here, and console log I, that will be 12. So that's what we get. The reason is var keyword. The var is what? Function scope. If you create a variable var inside the function, that means you have access to that variable anywhere inside this function, anywhere you can access. So whatever the value of that variable, right, you have access to that one. Clear now? Okay, but you know, how you gonna fix this, right? What we said, let and const block scope. Block is this is the block, right? That's the block. So if I change this one, I just change here let and let, right? Let's make it let, because let is a variable. Okay, is a variable, not a constant. Let is a variable, because I has to be changed. It's vary, right? Changing all the time. If you put const, then I become constant. Okay, const, right? Let is a variable, it is changing all the time. Okay, so if you do that, now what gonna happen here? Do we think we still have access to I? Because I, let is a block scope. Let and const is a block scope. Okay, let's go back and check. Look at here. I is not defined at ABCD. So you printed up to 11, and then when the control move to line 5, it says uncut reference error. Reference error means I is not defined. I is not defined at ABCD function. Okay, line 5. Clear? So let is what? Bracket scope, or braces, right? Braces scope. Clear now? Clear. That was the clear now, everyone, on that? All right, please ask me, okay, if someone has doubt, right? Collab, that's clear? Okay, so please ask me. Okay, so that was the one. Okay, that was the one explained. Var scope is, var is a function scope, right? So that's why these things, you know, this topic, right, once the class is finished, maybe today in your free time, you go back and do the revision, and then make a note here. Everything is written here, right? Look at the, even watch the video, quickly make a note in your book, and then repeat, understand, right, that terms, you know. So what is the difference between let, var and const, in something like that, right? Try to understand. Okay, so last one, right? There is 3 differences I say we're going to talk. So we just finished 2, right? Here, last one. Var can be used in any place inside its parent function, right? Okay, because of the function scope. That is done. If we change the var to let, then I is not allowed to use outside, right? Because let braces scope. Because of the let, right, braces scope. So the last difference is here. Var adds itself to the window object, and let and const does not add to the window object. Let and const creates separate script scope which is outside of the window object, right? Basically, remember, variable does what? Means when you use keyword, right, var, let, const, they create a memory. They create what? Memory. So var adds itself to the window object. Okay, window. What is window now? What is window object? So we will come next, right? So let's look at with the example. So var is adding to the window, let and const does not. So go back now and let's experiment, right? So what I will do, I will create a variable, let's call it var, right? Var a equal to 25, clear? And then I say let b equal to 35 and let c equal to constant, right? Maybe 3.674, whatever. Okay, you can put anything here. This is just the data type. So let's see what happened now. So go to the browser and we didn't console log yet. So what we're gonna do, right? Look at the source code here, source, and try to understand. So I will click on script here, right? Script. Oh, there is error. Okay, so let's clean that error for now, right? Let's clean that up. So here what I will say, for now I'll just give it var here. Okay, simple enough. So there will be no error, right? Yeah, the error is gone. Okay, so what I said, just pause here, here, and here, right? Here, and see what happened now. It is refresh. So the window scope, look at the scope now. What is the scope now, right? Scope. Okay, scope means where you can access, right? Where you can access the variable and function. So right now we have, we have what? ABC variable and then ABCD function also. Okay, so let's because we didn't pause this, right? We don't gonna see here right now, but anonymous function is there. Anonymous, not anonymous function, but we can call it anonymous is basically the execution context, right? The global execution context. We will talk about that in the coming later, right? Today, what is execution context and all that. But look at this A, B, and C, the variable B and C, right? Inside the script, that is separate. Okay, script. They create separate block of memory, right? And global is window here. So you're gonna find A inside the window. So var creates its memory inside the window. Basically, you can call it variable var, right? Var add itself to the window, and the let and const is outside of window, that is inside the script. Also there will be block, right? Because they are inside the curly bracket. So if something is inside the curly bracket, that will be in the block. So let's look at that also. Let's see, just experiment what can happen if I just put here curly bracket, right? And I say let d equal to maybe 100. Okay, and let e equal to 200. Simple enough. So that's the braces scope, right, for let and const. So see what happened now. So B and C you see, right, but you don't see this one. Okay. Oh, we did not pause, right? Okay, let's add the pause. Okay, you see that script is still there, right? Okay, let's pause this. A, B, C, D, that is part of script. So we are not executing any code. So inside the script we don't have D and E, right? We don't have D and E here. So you don't see the D and E, right? Because they are inside the braces. Okay. So sometimes so this is not executing yet. So let's go line by line. Let's click and see what happened. Click here. The code is in line 35. Okay, I mean there is no stop, so this is done already. A 25 is done, right? Look at here. A has a 25 value, finish. Now B will 35. B is 35. B is 35. It will add 35 to B now. Okay. Now move to C, right? Because code is executing. See what happened? Memory created first and the code execute, right? After. So now the code is executing, and that is what we have in pause mode. And C will add 36 whatever number there in the C. Okay, yeah. Now finally we move to the block because of the block scope, right? The block is created here. Look at the block, right? D and E. It's time to execute for D and E, right? So it will add D now inside the block and E inside the 200. Okay, so the block is gone because the work is finished, right? So it's already out of the memory. Okay, so I hope that is clear now, guys. The let and const is a block or braces scope, and the variable or var is a function scope. You know, var is the old, let's repeat, var is the old JavaScript, let and const is a new JavaScript. That is first different. Second one, var is a function scope and let and const is a braces scope. Second difference. Third one, var add itself to the window object. Let and const is outside of window. Just remember it's just remember it's outside of window, right? It does not add itself to the window. Clear? So it is outside. Fine. So that is the main difference within the let, const and var. And see all the variable, right? They get undefined in the beginning. See, B is undefined, C is undefined, A is undefined. That is the value assigned when the memory is created. Now when code execute line by line, then the value will be added, right? Okay, so A, now the control, see the cursor, the control is at line 10. So when you click, it will add A equal to 25. So 25 will be added to the A now. 25 added, right? See, similarly now B will add 35, C will be 367, this number, then this block will be created, and then number 10 and 200 will be added to their variable, right? Okay, so we understand the difference between let, const and var. Fine, so let's move at the next step. So what is next now? Okay, so var add variable to the window object. What is window object? Also called JavaScript global object, right? Global object. So what is window object now? Window object. So when the when you load the browser, right, in our when you run the browser or your code, what happened? The browser gives us something, right? Some object, some browser has something which is very important for our JavaScript program. That is window object. Okay. So what is the definition? Let's say some definition. The features which are not part of JavaScript engine, but okay, the features which are not part of JavaScript engine, right? But we are using in our code. Then these features are coming from a browser object called window. Okay, so can I reread this? What that means, right? We are using a lot of feature in our JavaScript, correct? So sometimes the feature is not the part of JavaScript, but we are still using in JavaScript code. Clear? So that features are coming from the object, right? Window object, which is the part of JavaScript. Sorry, part of window. It is coming from the window, right? So window is coming, sorry, let's repeat, right? The window is coming from browser. Browser gives us the power, right, of window object. Window object has a lot of functionality, which is not the part of, which is not JavaScript. It's just a window or the browser things, okay? And that functionality we can use in our JavaScript. Like you have seen alert, right? Alert. What is alert now? So if you put this function alert here, it will just add the alert, right? Like this. So this is what? This is window object. This is window property, right? Window is coming from window. This is not a JavaScript, okay? Built inside the window object. So if we run now, you can alert something here, right? Maybe string. So this is alert. allowed. Simple enough. So when you, okay, so let me remove all this, right, so that you can see that. So see, we get this is allowed, right? See that is the allowed. So to display this kind of some kind of alert, right, in your browser, basically you can use alert function, but that function is window object property, not the JavaScript. But we can use it, right? That's okay. So what else there? So like same thing, prompt, fetch API. Remember fetching data, set timeout, console, set timeout, right? Console, even console, all these are, there are many, okay? I just put couple of example, right? But there are many properties, right, in the window object, which is basically not a JavaScript, which we use on daily basis, right? Clear? Okay, so if you look at here, mainly browser gives us three things, and we call it browser context API. So what is browser context API, right? When the browser load in our computer, it comes with window, stack, and heap memory, okay? Window, stack, and heap memory. So what is window? So window is the object in the browser which is loaded with, loaded means it has many functionality, right, which are very helpful for our JavaScript development process. Okay, clear? So the stack. So let's look at the definition here, right? You can read through this one, I just get this from the internet. So the browser context API, I mean the term here, browser context API. The browser context API is an interface, right, provided by modern web browser. Means it's just the interface is just kind of an object, right, or some functionality given by the modern web browser that allow developer to create isolated environment, right, known as browser context within a single browser instance, right? I mean one browser, each browser is the one object, okay? Each browser context has its own set of resources, right, such as cookies. See, browser has cookies, storage, cache, providing a way to separate different web browsing session, right, or application within the same browser window or tab. I mean, it's more like a details, right? But when the browser loads, it has a lot of things built inside, okay? So if you make a, let's say this is one page, right? This is one page. If I make another page, every page here have things built inside already. If I inspect this, and go to the console, right, I can type here window. See, I have access to window now. See that is the window, right? And see, this is the alert function, right? You can see set timeout, maybe clear timeout, clear interval, clear time, closed. You can see, let's go back down here, fetch here, fetch function, okay, find, focus. So there are so many here, functions, right? We even not use maybe 0%, something like that. Just use couple of, so all the events on mouse over, mouse click, all that, right? On mouse scroll, what is that? Mouse scroll, on resize, on reset. Okay, so just remember, this is the functionality the modern browser give us, right, to use. Okay, so that's the window. That's window, right? Okay, let's go back. The stack. What is stack now? So you can read the stack. So there is stack and heap memory, right? So here is the heap memory. So what is memory, right? Remember, we have function, we have variable. Anything else you have? Function and variable, right? So basically the heap memory is kind of like intermediate memory, right? Intermediate memory. Okay, let's take one example now and try to understand what is intermediate, right? Let's say you have a 1 plus 2 plus 3 plus 4 plus 5 plus 6, right? You need to count all this. How are we going to count normally? How? You say 1 plus 2, right? 3. 3 plus 3 is 6. 6 plus 4 is 10. 10 plus 5 is 15. 50 plus 6 is 21. 21. See how you count? We just not gonna put 21 here, right? You have to add, right, all that. So similarly, the when we adding, right, 1 plus 2, what we have done, let's put it here, right, 3. So where this 3 will go sit there, where this 3 will go and stay in the memory. Computer does the same thing. Computer will not finish all this in one time and display the result. No, it has to go one by one. So it will store maybe 1 in the memory, right? Then go next. Let's say it will store maybe like this, 1. It will find 2, right? Oh, 1 plus 2, 3, 3, right? So 3 is in the heap memory now. So intermediate memory, right? So when you do calculation, the value in between, okay, is stored somewhere in the memory. That is called heap memory. So just to make it simple, I just do this, right? So just if in the interview they ask you, right, how many different kind of memory, maybe you can call it stack and heap, right? Heap memory. So what is heap memory? Short-term memory or intermediate memory, right, which holds some value for the re-evaluation, recalculation. Okay, so 3 now. So now here is 4 already. 3 plus 4 will be, what is that? Okay, 3 plus 3, this is the 3. 3 plus 3 will be 6, right? And 6 plus 4 will be 10, right? 10. And 10 plus 5 will be 15, right? 15. And 15 plus 6 will be 21. So final answer, that is what you will see in your result. Okay, that's what you see, the result, right? Result. What is your output? The result. That is the one. Okay, so if you read the heap memory definition, right, in programming, the heap is a region of memory to use for dynamic memory allocation. Dynamic memory, something changing all the time, right? Okay, it is a large pool of memory that store objects and data structure created during the execution of the program. So when program runs, first it will create all the variables, memory for all the variables. Okay, for the function also, they all created in heap memory, all created, right? But now something is changing all the time. If you have to do calculation, some short term of change, right, in between, computer do the calculation in its own way, right? So it has to store the last value somewhere, and that is storing the way it is stored, right? That is all happen in heap memory. Okay, so just remember something like that, right? You can remember this example what I show you, right? Okay, but what is stack now? What is stack, right? The stack is another region of memory, means it is against next region. One region is heap, the next region is stack. Like in the memory, you can have many regions, right? But right now we are looking at heap and stack. So what happened inside the stack memory? What happened now? So stack is another region of memory used by program, including JavaScript programs. It is a specialized data structure that store information about function call. Okay. Function call, right? And the execution context. Oh, here it comes to execution context now. Execution context, right? So when the function executes, what happened? It creates something, right, inside the stack. Now all that process happen inside the stack. The execution context is taking place inside the stack memory. Okay, the stack operates in last in first out, LIFO, at last in first out manner, meanings that the most recently added item is the first one to be removed. Okay, just remember this, last in first out, right? So let's do some simple example here, and I think that will help us to understand execution context also. So let's say I have one function, right? Function, okay, let me delete this. So how function execute? Okay, so we'll check that one. Function, right? Foo, okay. So let a equal to 5. Then you have again another function inside, hide, right? Console.log high. Let's call it a. Okay. So let's have here, right? Let maybe b equal to 20. Okay, good enough. So what is execution context, right? That is what we have to understand. What is execution context? So execution context is the step-by-step process in which each line of code is executed. So how that happened, right? My God. Okay. So execution context is what? The process, right, in which line by line code is executed in our memory. So if that all happened in the stack, right, in the stack. So okay, let's understand the execution context. So if I have to run this code, right, how it will work now? How? So it will create a box, separate memory box, right? The foo in the name of foo. Now the function will create a memory box. So let's say like here, right? Oh, I should have connect my writing pad. So let's say when the foo runs, I will copy this. Let me just put it here, okay, for now. No. Okay, just paste here. I cannot. Yeah. Okay. So when foo runs, it will create what? It will create execution context. Let's call it EC, right? So that is what? That is the imaginary. Just imagine it is a box. Box. Okay. The memory box is created in the stack, right? So it has two part now. But it has two part, right? So the first part is memory, right? And the second part is code execution, that is EC, okay? So when the memory created, what happened now? The foo is created here, foo, right? Foo is a function, okay? So that is just a function. The whole function, this whole function is here. Now inside the function, I mean, rest is all inside the function, right? So this is called global execution context. Okay, this will be created first. It will be added to the bottom of the stack, right? Okay. Now what I said, right? When you have function always creates the new execution context. So let's say this is a function execution context, right? This is a function execution context. So this will be now, this is what? So when this will be created, right? When it will be created? When the function execution context creates? When you call the function, foo, right? Somewhere in the program, every time it's gonna create this function execution context. Okay, it will create that. So it has the same thing. It has a memory and code to execute. Memory has what? Now a will be added here. A equal to 5, right? I mean, it will be undefined, then later it will add 5. And then it has another function called high. So high will be just added here. Function, right? That's it. Then what happened now? Let's say inside the code here, right? You executing high also inside the foo, okay? You execute high. Then high function will create a new execution context again, right? So that will be memory and code again, same process. Okay, so in this case, right, let's say how the high can use a now. How? Because a is outside, right? So always remember, child function can always use the parent function variables or any function variable, whatever it can use. Okay, it has access, right? So, but how that happened, where it get access, how it access, right? So that is called something lexical environment, right? Lexical environment. So let's read out a definition here, right? Where is our definition? So in execution context, when function is called, right? When function call means what? When function is executed, it creates imaginary container where three things are stored, right? Okay, simple. When the function is called, it creates imaginary container, means just imagine it creates a box, right? Function execution context is created, and where three things are stored. The first one is variable, child function, and the lexical environment of that function. Okay, so again you get lexical environment. What is lexical environment now? So you can make a note, right? Lexical environment. Okay, so lexical environment is some kind of like a log, right, or maybe chart, which keeps record of the current location, current function, variables and function, and its parent lexical environment. Okay, means its parent lexical environment. So what is lexical environment? So lexical environment is the record of its current variables and functions along with its parent lexical environment. So parent can have again another lexical environment, right? Why? Because it may be the child of another function, maybe like a, see, this function lexical environment will have record of this variable and also the parent, this foo parent, right? Parent lexical environment. So parent has lexical environment, okay, which has a record of a and whatever in the global, right? Global. If there is something in global, it has access. So lexical environment, see, its environment plus lexical of the parent. So that parent lexical environment is what? Everything inside the parent, like a or anything from the parent variable, right? It has access. So that's why the child can access the variables and functions of the parent because of the lexical chart here, lexical environment. So just tell me now, right? Lexical environment is clear or not? I know it's confusing, but tell me. Lexical environment. Anyone? I mean, who understand 100% and who has understand 5%? Who understand only 5 to 10%? Okay. So Olebang is 100%. Okay. Uh,
Zimbin is 5 to 10%.
Okay, good, very good, right? You have to tell me, right? That's good. Any more? Anyone more? Okay, so this is one thing, right, which is very important for us to understand. Okay, so let's try to. So let's read through this quickly, and then we're gonna make one example. So lexical environment is like a chart which stores the address of local variables and functions along with its parent lexical environment. So okay, so now here, right, I think in our last exercise, let's see if there is something. Okay, we don't have that. Okay, so we will just take this example. Okay, So how I can explain that? Let me just give me a second. I will connect my tab to right. I forgot I should have connected earlier. Okay, so in this function, if you look at here, right, so you have function a, function b, there's x, then x again here in the another function, because they are function scope, they are separate, right? X10 is for this function only, x is for this function only. Okay, so okay, let's go back here. I will clean this up. Yeah, I can write. So see this code, right, the code we had earlier, this code, let's say there is one more, right? For example, this high is executing here like this, and then foo is executing here, right? Simply because this is in the global. So a, b, so how, right, how the high function have access to a now? How that is the point. So if there is one more function inside, right, function, let's say last, okay, and it can also access, right, log last, it can access a again, or maybe b. Okay, you can access a, let's console log b also, and then you can execute this last, right, last here. Okay, so I will just copy this and let's go back to the okay, so you have a high function b20 console log a last. I think we missed the top one, right? And okay, now it's fine. So the first function, right? So let's try to understand the execution context, EC, right? EC. Let's try to understand EC. Okay, that is what execution context. So first, what can happen, right? Let's say this program run. Okay, this program run, right? It will create the memory box, correct? Just imagine it will see how the code running. Just imagine, right? Code is running now. Code is not running, but let's say code run, but the steps, what gonna happen after the code run? Steps, right? So this execution context is created simply like this. Imagine this. So this is a memory, and this is a code to run, right, to run. So the code will not run fast, it will create a memory. So what is the memory now, right? And this is a global, the first one is global execution context, global execution context. So in the global, what we have now, let's look at the variable and function. Always look for variable and function. That is the foo, right? Foo function, foo. So that is foo function, that's it, and it will store the all function definition, the whole thing. Okay, so we have to call the foo here, execute foo, right? The foo execute, because without execution this will be not created. Right now we don't have anything. Okay, so when the foo execute, right, when this code run, it will create this box, memory is created. Simple. Now there is a function, foo is a function, right? Function, it execute. So when it execute, just imagine, okay, so let's make one call stack also, call stack, right? Stack, call stack. Okay, so here global execution context, last one is added, right? So when this box is created, it has what? It has the variables and function information and the lexical environment. So here is what? Lexical environment also. So this is a global. So global does not have any parent. So right now it will be equal to null, 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 null. Okay. So global lexical environment is equal to null because there is nothing after that. Fine. But the foo function execute. When it execute, it will be, see, when this execute, right, just imagine when the memory created, this function is added. Now code start running, the first line will be here, execution of this function foo. So it will create the imaginary box again, right? Every function will create the new execution context. Okay, that is, this is a foo, right? Foo execution context. Okay, just imagine that. Now that will be have same thing, you know, the memory and variable. So what is memory and the memory? What is memory in the foo now? A, right, will be undefined for now. And there is a high function, high, right? So high will be everything, the whole definition of the function, and that's it, right? Memory created. Okay, memory created. So code run now. Foo is what? Foo is a, right? The first line will be this line, a equal to 5 added here. Then high, nothing gonna happen. Let's say high here. See, it execute, right? So the high will execute, it will create the next memory box again now. So see, the foo is inside added already, foo here now. The foo is in the call stack already. Okay, so the foo has now lexical environment, right? Lexical environment. And what is in the lexical environment? So foo contains local memory plus parent, the parent lexical environment, so parent lexical environment. Simple. So that is null right now, but it has local memory, right? Local memory. Foo has the local memory. So what is local memory in the foo? A and the high function there. Okay, fine. The high execute now, right? High execute here when the code run, right? High execute. So it will create a new execution context. So that is memory and code run, right? So in high, what we have now? High, where is high? Here. So memory will create for B, that will be undefined, and oh, there is a function also called last, right? So it will be last function, that is function. Okay, that's it. Now code runs. Once the memory creation finish, code will execute, right? Because once memory created, this is already inside here now in the execution context. Okay, so that is high, right? High. So high is what? High gonna have local environment, local memory environment plus parent execution, parent, what you call that, lexical environment, parent lexical environment. Okay, there is already the, like a chart, right? It has a chart called lexical environment. Same thing here, right? Okay, high run now. So B will be, the code execute, right, in the high function. So B, it will assign 20, and after that console log A. So console log A. Now let's imagine here we have console, right? Console, because the high function is running right now. Okay, so console log A. So see, now the interesting, where it getting A now, the high function is getting where. So high has access to its parent lexical environment. Who is that? Foo, right? Foo. So foo has local memory plus its parent lexical environment. So foo lexical environment is what? Everything here. So that is local memory and all that, right? So that local memory has A. See, the foo has local memory A. Look at here, foo has local memory A, right? And that's why high get access to that A. So console log A will be 5 printed now in the console log. Okay, so okay, fine now, right? So that is a function, let's say last, and again console log B now, right? Console, no, that is the last. So I think that's it, not that, not only that, now we have this one, running of the last function. So the last function will run also. So it will create again next memory box and code to execute, right? So this will be pushed inside the call stack. Okay, so that is last function. So it has again the lexical environment. So that equal to what? Local memory plus parent lexical environment. Okay, so parent means what? Lexical environment means, see, the high has everything from all the way down. So that means last will get everything all the way down, right? All is parent, grandparent, and grandparent. Every memory information last has access to. So let's look at now, right? The last will be, there is no variable and there is no function also, nothing, right? So the just code will run now. It will console log A, right? Console log A. So A, it will look where? It will go look in its parent. Who is the parent of last, right? That is high. Okay, so high, it will look in the high lexical environment, correct? It has already access here, right? So that's what it is looking for. And it will not find in the high, then the high has access to its parent, that is foo, right? Foo environment, and there it will find A, that is 5. So it will just console log 5 again here. Now console log B. So the B, it will look in its local memory, it will not find, it will move to its parent memory because it has access to the parent lexical environment, correct? It will look there, B, right? So that is B. Oh, there is a B, 20. It will print 20. Okay, 20, right? 20. So once that is done, right, the code execution is finished in last. Remember in the stack what happened? We say last in, first out. The last in is done, right? It will be out of the call stack, gone out, finished. Now high, right? High is what it's doing now. So once the high, this is done, right? This is done. So last is done. Then it will move to the high. So it is already finished, right? It is already finished. So it will be out from the memory, out from the memory, out from the memory. So the code is execution finished, right? So that's why it will be out of the memory, out of the memory, out of the memory, means out of the call stack. Okay, now tell me, right, is that helpful or not? Let's see.
it's helpful, Deb.
So that is, the lexical environment is, and that is called chaining, right? Lexical, what is the lexical chain scope? I mean, what was that word, right? I think lexical chain, right? Something like that. I even forget, So that is the scope chain. Okay, scope chain, right? What is scope chain means? The child has access to its parent lexical environment, and it keeps chaining, right? Chaining, chaining. So if you look at here, basically this one, right? This has access to its lexical environment, it has access to its parent lexical environment, and it has access to its parent lexical environment. So that makes a chain, right? So we call scope chain. So what is scope chain now? Okay, let's make the scope chain. Scope chain is just the accessibility, access to its parent lexical environment. That's it. So they form like a chain. Okay, so that is scope chain, right? Scope chain. So see, that's the way the whole code run, right? I mean, I can show you now in the let's go back, right? Let's look at this code here. Okay, let's exact what we learned. Let's experiment in our browser. Okay, this code only, right? The foo. So what I will do, I'll comment out all this for now, and we have only foo, right? So foo is let's running here, and then we have a high will run here, then we have a last will run here inside the high, right? Yeah. So let's go back. So I'm gonna, okay, so we have what we get, refresh. Okay, we get this code now, right? So I'm gonna just stop here, this one also, this one, okay, this one, the last, and high, and foo. So foo, I have paused all the code now, right? When I run this program again, look at here, anonymous. What is anonymous now? That means the global scope is added inside the call stack, the stack, right? In the memory, the global scope is added already. Okay, line 39. And what is the line, right? If I say control means what? Control means the code, where the code is running, where the next line of code is running now, right? So control is right now in line 39. Simple. What is here now? This is the function foo executing. So that means this function foo execute. So that is what, this one, right? So that should be pushed inside the call stack, our call stack here. Okay, so this is the anonymous, this is anonymous global. Now foo will be added to the call stack. So let's check that now. I will click on the next step, right, and it will see. Now the last box is the anonymous, right? The global execution, the foo now added to the call stack. Look at here, foo added to the call stack. Simple. Okay, so the when foo added, right, it creates the memory box and all that. So what are the memory now inside the foo? So you have a, right, a memory. If you look at the foo, right, it has a memory a which is undefined, and the function high, that is the memory. Okay, now the code inside the foo will run. So see, the control is in line 5 right now, line 5, right? So when I click, the a get 5 value, and then control moves straight to the execution of high now, because function high is already there, right? It's already there. Now it will look for the next step to execute, do something, right? That is high function. So when I click next step, high function will execute. So when the function execute, what happened now? It will be pushed to the call stack. So see, now high function pushed to the call stack. It creates its memory box now, right? And all that. So So high has a the b, right, memory b, and the function called last. See that inside the memory box. Now the code will execute. So the control is in line 26, that is b, so it will add 20 to the b, and I think after that there is nothing, so the execution of this function, right? So let's execute that. See, so now the control is in last function, right? It's executing now, it is executing. So that means it will create a new memory box and push to the call stack. Means it will create a new execution context and push to the call stack. See that? So the global, foo, high, and last, right? That's it. So now console log, and look at the closure, right? That is a closure now. See, they are forming closure also. Foo makes closure, high makes closure. So once we know the scope chain, right, and lexical environment, it will be easy for us to understand closure also. The closure is nothing but the scope lexical environment, like how it remembers its parent variables and function, right? Because of the closure. Okay, so if I open this, see, a, there is a, right? It's in the closure now. That's why this is a b now. Okay, so let's run now, right? Console log a. So because of the closure has a already, closure has b already, they will get the value there. Means last has access to all this closure now. That's the lexical environment, right? So if I click, it will print a, right? So if you go to the console, we have 5 from before, and then it will print again the next one, b, right? B. So that is 20. And after that, what's gonna happen? It should see the last done, right? It is almost finished, so it will be pop out of the call stack now. So last in, first out, LIFO. So last gone, high will be gone, and then foo will be gone, and finally anonymous, right, will be also gone. Means it just run again, it's showing there, but it's all finished now. The program is finished, right? So that's how the code works, and that is the lexical environment and scope chain, right? Scope chain is nothing but it forms like a chain, you know, from child to parent, right? Lexical environment. Okay, so that was the lexical environment. So we understand execution context already, right? It makes a global execution, function execution. We have understand all that. If you want to read through, you can read that. So truthy and false we talk about yesterday, you know. Anything you write in the JS is mainly below to one of the type, right? Mainly belongs. Okay, I typed wrong here. So anything you write in JavaScript code, anything, any code, any data type you write, right, it belongs to two types. Sorry, one of the type, right? Either true or false. That's it, truthy or falsy, right? So falsy value, if you know what is falsy value, then remaining all is truthy value. So what is falsy? 0, null, undefined, false, not a number, and document all, right? Document at all. That is a falsy value. The remaining all is truthy value. And we saw the use of study, right? In your condition, you can add and check, right? If you have to check, anything that is falsy or truthy, you can check. Okay. If something is equal to not a number, right? If that is true, then that is falsy. If that is false, then that is, you know, truthy value. False is truthy, falsy value. So just remember that all these are falsy. And there is a use case. You have to, when you want to test your data, right? If there is something or not. Falsy means nothing, right? So even you fetch data, and sometimes you want to test when the data has value, that is when it is truthy, then only loop through that or do something, you know. You don't want to loop the array, right, until it has some value inside. You must check it. write a condition if there is something, means if that is not falsy, then do the loop, so there will be use cases when you when you code. Sometimes you'll see all that. So let's keep it up to here on today, right? And then we will continue with the next step. I hope whatever we have learned, try to make some simple notes, right? And that terms, try to understand that. Okay, if any confusion, you can ask me again tomorrow. Okay guys, so please continue with your exercise now, and later you can ask me if there is any issue with your problem solving. Any question on that, right? You can ask me. Okay guys, so I will stop here.